When you hear about your organs, you probably think of your heart or your liver or your lungs. Maybe you picture Captain Nemo playing the organ aboard the Nautilus. Why do they have an organ on a submarine? Doesn't make any sense. But your first associations with that term probably overlook your biggest organ. I'm talking about your skin. The glorious, fleshy shroud that keeps the world out and you in. Your skin protects your body against infection and extreme temperatures, maintains your balance of fluids, and even synthesizes vitamin D for your own personal use. Its many nerve endings allow you to sense the outside world, and its sweat glands and blood vessels help you maintain a proper temperature and communicate a whole range of stuff from your health to your emotions through things like blushing and flushing and sweating. It also accounts for about 3 to 5 kilograms of your body weight, and if you could spread it out, it would measure up to 2 square meters, enough to cover your bed. The most disgusting, paper towel thin, waterproof, insulating, stretchy, self-repairing, lifetime-lasting quilt on the planet. It comes in lots of different colors. You can cover it up or show it off or tattoo the periodic table on it if you want. And of course, without it, you would basically shrivel up and die in no time. Together with your hair, nails, and sweat and oil glands, your skin forms your integumentary system. And if you've ever been burned or had surgery or stepped on a nail, you know how fast complications arise when it gets damaged. But it also heals up quite quickly. Layers. Like an everlasting gobstopper, the key to your integumentary system is layers. And although you can't tell by looking at it, your skin actually has 3 of them, each with particular types of cells that have their own skin jobs, to borrow a phrase from Blade Runner or BSG, whichever you like. The epidermis is the only layer you can actually see, assuming that your skin is intact, which is why it's what you think of when you think of skin. It's made of stratified squamous epithelial tissue. But the dermis just below it is where most of the work that skin does gets done, like sweating and circulating blood and feeling everything everywhere all the time. And at the bottom, there's the subcutis, or hypodermis, composed mostly of adipose or fatty tissue. Each of these layers owes its properties and its ability to do its skin job to its unique combination of cells. The bulk of your epidermis, for example, is made up of cells called keratinocytes, which are the building blocks of that tough, fibrous protein keratin that gives structure, durability, and waterproofing to your hair, nails, and outer skin. These cells are constantly dying and being replaced. You lose millions of them every day, enough to completely replace your epidermis every 4 to 6 weeks. That's why if you want to tell the world you love your mom or commemorate your favorite famous physiologist with a tattoo, you gotta make sure the ink gets below the epidermis. If there's a cell in the human body that's been responsible for causing the most pride and the most prejudice in human history, it's another epidermal cell, the melanocyte, the spider-shaped cell that synthesizes melanin, the pigment that gives skin its color. I'll spend more time talking later about why skin color differs around the world, but one thing to keep in mind is that both the very palest and the very darkest human skins on the planet have about the same number of melanocytes. Your particular color isn't about the number of these cells that you have, but instead about the breadth of their spidery cellular extensions, which in turn affect the amount of melanin that they contain. But on a cellular level, we're all the same. Now, your skin, obviously, is also your first line of defense when it comes to protecting you from the outside world, so it may not come as a surprise that you have lots of immune system cells in your epidermis as well. These are your dendritic or Langerhans cells, which are kind of star-shaped, and like white blood cells and platelets, they actually originate in your bone marrow. Once they migrate to the epidermis, their long, skinny tendrils run around the keratinocytes and spend much of their time ingesting the unwanted invaders that are trying to sneak around your skin. Finally, rounding out the quartet of epidermal cells, your tactile, or Merkel cells, occur deep down at the boundary between the epidermis and the dermis, where they combine with nerve endings to create a sensory receptor for touch. What's a little weird, though, is that all of these cells are organized differently in the skin that covers your body. In fact, in some places, you have more layers of epidermis than others. Your thick skin, and yes, that's what it's really called, is the tougher stuff on the palms of your hands and the soles of your feet, and it consists of 5 epidermal layers. Your thin skin covers everything else with just 4. To get to know what's going on with your thick skin, let's just imagine you're walking around barefoot in the yard and suddenly you feel a shooting pain. You've just stepped on a big old nail, and it's penetrated all of the layers of your epidermis. First, it pierced your stratum corneum, which means, pardon my Latin, horny layer. This is the outermost layer and also the roughest, made up of about 20 or 30 sheets of dead keratinocyte cells. This is the layer that you're always sloughing off and feeding to dust mites, but while it's in place, it offers basic protection from environmental threats. From there, the nail drives through your stratum lucidum, or clear layer. This holds 2 or 3 rows of clear, flat, dead keratinocytes that are only found in the thick skin of your palms and foot soles. So in places where you only have thin skin, this layer is what's missing. Things start to get more serious in second granular layer, or stratum granulosum, because this contains living keratinocytes that are forming keratin like crazy. This layer looks kind of grainy because those cells are getting compressed and flattened as they move up through the epidermal layers, maturing as they go. The deeper you go through the layers of the epidermis, the younger the cells get. Regeneration happens in the lower layers, and new cells move up toward the surface, maturing along the way, where they eventually die and slough off from the surface of your skin. This whole process is due in part to the fact that the epidermis is epithelial, so it's avascular. That means that all the oxygen and nutrients that its cells need have to come from the dermis below it. So as epidermal cells mature and get bumped up by younger cells forming below them, they move further and further from the blood supply and end up essentially suffocating. When that nail cuts through the fourth layer, the stratum spinosum, or spiny layer, it's getting closer to the point where cell regeneration, or mitosis, is active. These cells look prickly when they're dehydrated from microscope slide preparation, hence the name, and that's because they contain filaments that help them hold to each other. And finally, that dang nail touches down on your deepest, thinnest epidermal level, the basal layer, or stratum basale. It's just a single layer of columnar cells, but it's like a cell factory where most of that new cell production happens. This stratum is also what connects the epidermis to the layer of skin below it, the dermis. Feeling a little overwhelmed by all the layers? Just remember, come, let's get sunburned. It's a mnemonic. I mean, though, who came up with that? Because if you own some skin, you know you don't want to get sunburned. The ultraviolet radiation in the sun can damage the epidermis, causing elastic fibers to clump up, leading to that telltale leatherface condition. Plus, getting sunburned temporarily depresses your immune system, because remember, you have immune cells in your epidermis too, and the radiation can actually alter your skin cells' DNA, leading to skin cancer. We're gonna go into your skin's love-hate relationship with sunlight more next week, but in the meantime, seriously, wear your sunscreen. Now, skin damage of any kind can get serious when it affects the dermis, because it's not only got loads of those collagen and elastin fibers which help make your skin strong and elastic, it's also full of capillaries and blood vessels. And it houses the nerve fibers that register sensations like temperature, pressure, and pain, as well as parts of your hair follicles and oil and sweat glands with the ducts that lead up to the surface of the skin. So the dermis is where most of the skin's work is done, and it does it in just 3 layers. The upper papillary layer is composed of a thin sheet of areolar connective tissue that's riddled with little peg-like projections called dermal papillae. These papillae are pretty neat because in the thick skin of your hands and feet, these tiny protrusions form unique friction ridges that press up through the epidermis to help our fingers and feet grip surfaces. Your fingerprints. Just below that papillary layer is the deeper, thicker reticular layer that makes up 80% of your dermis, made up of dense, irregular connective tissue. All of the dynamic parts contained within the dermis, like the nerve fibers and capillaries, are distributed between both its layers. So anytime you get cut enough to bleed or feel pain, you know that you've broken through the epidermis and lacerated the dermis, which, by the way, is the layer that tattoo needles have to reach in order to work. It's the only way to make tattoos permanent, but also it means getting tattoos hurts and bleeds. Finally, something of a footnote to your skin is its third and most basal layer, the subcutis or hypodermis. It consists of mostly adipose connective tissue, basically a seam of fat, and it provides insulation, energy storage, shock absorption, and helps anchor the skin. In short, your hypodermis is where most of your body fat hangs out. But there are more skin things to discuss, so in our next lesson we will tackle big questions like, does lotion really do anything? How does deodorant work? And what will make my hair soft and shiny and irresistible? For now, though, you learned all about skin, the main organ of your integumentary system. We looked at the structure, mechanism, and function of your 3 layers of skin, the epidermis, dermis, and hypodermis, and their various sublayers. We talked about the roles of melanin and keratin cells, what happens when you step on a nail, how to ensure you get a good tattoo, and why it pays to wear sunscreen. Thank you for watching, especially to all of our Subbable subscribers who make Crash Course possible for themselves and for the world. To find out how you can become a supporter, just go to Subbable.com. This episode was written by Kathleen Yale, edited by Blake DiPastino, and our consultant is Dr. Brandon Jackson. Our director and editor is Nicholas Jenkins, the script supervisor and sound designer is Michael Aranda, and the graphics team is Thought Cafe.